Hi all, welcome back. So today we are starting this series. We will solve previous year questions, gate previous questions, and of control systems. So this series is really going to help for those who are preparing for preparing for gate exams like electrical, EC, and instrumentation. So in this video we will solve one questions and related topics and concepts required to solve this question we will also try to explore. So all right, let us try to solve this question and related theory and concepts required we will try to explore. All right, so this question they asked in this year 2025 GATE electrical paper, and they're saying that open loop transfer function of system shown in figure is gs equal to k into s plus 2 by s plus 5 into s plus 7. So as we know, numerator polynomial gives the 0, and denominator polynomial gives the poles. All right, so number of poles is here 2, and the number of zeros is also 2. All right, so here, so which of the following real axis point is around the root locus? So they are saying that k, our gain is greater than equal to 0, and they are saying that real axis, let us draw the s plane. So this is omega axis, this is our real axis sigma. So here one pole we are presenting the representing the pole is 0 like circle. This is 1 0 minus 2, and cross we are presenting the pole minus 5, and this is a minus 7. Okay, so if they want that which they are giving the like minus 1, minus 4, minus 6, and minus 10. All right, so they are saying that which real axis points, I mean minus 4, which real axis points or the root locus, lie on the root locus. So this is a more than one option correct, I think. Yes, so here so what's how to solve this? Let us go through the root locus rules and concepts. Okay, then we will come back to solve these questions. So our agenda is that the we will cover the important concepts which are frequently asked in exams through the questions. Okay, so like in root locus, what's the concepts and rules and significance, and what's the root locus? So we have explained here like graphical method to analyze how the poles of closed loop system moves as the system parameter. Generally we vary the gain k. Okay, so in an s plane, okay, in our root locus just like a path we can say, path of the poles, okay, closed loop system, the poles how is varying. Okay, so that's a way we can understand and helps visualize the movement of the poles. Yeah, how the system poles vary in the complex plane. Complex plane means that in s plane. Okay, s plane sigma plus j omega. So this is like a classical control design. We use the root locus to design the controller. All right, so this is like additional things we are trying to understand. Okay, so that's a root locus. we are giving more simple way here to understand this. And what is the significance of root locus? The stability analysis determines if poles cross into the unstable right of the spline. As we know, in our stable system, all poles should be in the left of the spline, right? Then only we can say system is stable. If you cross the right of the spline, then it is unstable system. So in case of root locus, we will see for what gain range and system is stable and what gain range system is going to unstable. Okay, so performance tuning is also important. Direct link to tangent response like overshoot, settling time and rise time, right? So here we also understand in case root locus, if you vary in the gain k, and of course both going to change. So in case of for given overshoot and settling time, we should know the our closed loop pole should be lie on the finite position actually. So that's important, then only we can achieve the our desired overshoot and rise time, setting time and all. Okay, so I'm just giving the importance here for the root locus and how we can utilize the root locus. So in case of gain selection, enables optimal gain tuning for desired performance. Yeah, so this is also important. If you vary the gain k in case of control design, if you vary the gain, and this also impact on the overall gain. Okay, we will explain this in upcoming videos. Okay, so it is helpful. And in case of control design, of course support the design of PRD controller. Okay, and other compensator like lead lag compensator, lead compensator. Okay, so based on our need, be a PI controller, PD controller. So based on our need, we can explore, we can design and meet the performance of the system, and provided system should be stable. Okay, so of course control design, we can design the controller for to meet the performance, of course, and like disturbance rejection, and noise attenuation, and of course stability should be maintained, stability should be achieved. Okay, so there are always a trade-off kind of nature in the control system design. Okay, if you want to meet the performance and stability, so how much controller is robustness, so for this we should analyze the control system. Okay, so yeah, so here we understood that like root locus works as like a tool for control design. Okay, so like in if you go for mathematical concept foundation for root locus, so this like Curtis equation. As we know, in case of unity feedback system, generally we could deal with the unity feedback system. So this like a GS our system. Okay, and and this is a plus minus. In case of our control system, we generally deal with the negative feedback. Okay, then only error can be reduced. Okay, so this my output, we can say by yes, this my reference. So here if you find out correct equation, so here closed loop system transfer function by s by rs, it come out to be gs. Here you put this like a hs also. Okay, you can see if you put unity feedback, so hs here is 1 actually. Okay, here we are putting general equation actually. Okay, 1 plus k into gs into hs equal 0. So here if you find out the closed loop transfer function, so gs by 1 plus k into gs into hs. Okay, here gs also is put the gain also, you can put here k. Okay, all right. So root locus shows how roots of this equation change with k. Open loop, this like open loop. Okay, if you cut this feedback, so gs into hs, so this is like numerator by denominator number will be there. So if you can close loop poles of the roots of the this will be closed loop poles. If you find out this, if you solve this equation, you will get the closed loop poles. Okay, So root locus basically this like a path of the poles, how poles vary over the vary of the vary vary the gains. Okay. So if you root local, I'm just read out the rules so that easily we can fresh of recall or rules. Okay, since in this question what's rules is required, we will explore more. Remaining we will not explore that much, and over based on the question needs we will explore the concepts. Okay. Number of branches equal to the number of open loop poles. Okay. So whatever number of poles is required, open loop poles, it is a number of branches. Start and end points begins the at poles. Of course, it start from the open loop poles, end from zero. Okay, if zero is not there, it terminates from infinity. All right. So the real axis rule. This rule will be useful in this question. So a point on the real axis lies on the root locus. Okay. If the total number of open loop poles and zero at the right of the point is odd. Okay, that's a very important, because the condition of the root locus, their magnitude condition and phase condition. Magnitude condition we will explain later. I think in the upcoming slide it will be there. So so consider the real number line where the poles 0 are located. For any test point on the real axis, count how many poles and 0 lie strictly to its right. If the count is odd, then the point belongs to root locus. If the count is even, the point is not the root locus. Why this? This follow from the angle condition, because our odd multiple of the 180 degree should be there. All right. Even it will not follow this condition actually. So on the real axis, the angle contribution for each pole or zero is either 0 degree or 180 degree. Of course, real axis only contribute either 0 give or 180. So counting the number of zero poles and zero is the right adjacent determines the total angle. And this is main part of the root locus, main condition of the root locus in case of contribution of the phase. So I given here gives poles at -4, -2, -0. This like one example. So this like a one pole, -2, -4. So if you just count this like this and this one, there are three region you can say. So here this is counted. It will be only one pole, right? So this will be part of this, and this is not part of this. Okay, because if you stay here and look into right hand side, so it will be two poles, it will not part of this. So this branch will not part of this, and this of course part of this. Okay, so that's the same thing they are trying to explain here. I'm just stating because it will be helpful to understand. Of course, in angle of departure, angle of arrival, this only applicable for the complex poles and zeros, right? Complex pole, it require angle of departure, and complex zero, it require the angle of arrival. All right. So this is simple way we can find out what's a complex pole. From there we can find out the our contributed angle. Okay, from departure angle we can say. Similarly for the zero also. We will explain this concept more in detail once we will get the related questions. We will explain more detail in this. All right. And breakaway break-in points from your breakaway will be like how to solve it. Dk by ds equal to 0 from this equation. Correct equation we can say here 1 plus k into gs into hs equal to 0. From where k you can find out and find out the derivative. All right. So in case of breakaway point only lie between the two poles. Okay, break-in points lie between the two zero. Okay, so that's the point you need to remember, important point. So angle departure arrival I already we seen in previous slides. Okay, and imaginary axis crossing. So use route harvest to find when root locus crosses imaginary axis. All right. So here in case of, like, for example, this my imaginary axis. If just random I'm trying drawing the root locus. So if you this crossing like that, okay. So this point, you can say this point, this point. So if you find out the you just use the route heartbeat, then only we can find out this point, right? Because that time our route heartbeat zero zero row will be lie, right? Okay, anyway, we will discuss these things also. Magnitude condition, this like magnitude condition, okay. So k into gs hs whole magnitude will be 1, okay. So if you any any points lie on the root locus, it should fulfill the ever both condition, magnitude condition or phase condition. All right, phase condition, this is phase condition, okay. Odd multiple of the 180 degree. So I'm just trying to explain here, like gs into hs, this like open loop transfer function. So it is poles there and no finite zero, okay. Three branches, thrh submitter, because there's no zero, because it is start from the poles and terminates from zero. Zero is not there, so zero will lie on the zero lie on the infinity. So that's why three asymptotes applicable. So asymptote angle we can find out, okay. So so this way we can find out. And just like a summary, I am trying to giving here. Root locus powerful graphical tool for control system design, helps analyze stability, performance, gain sensitivity, okay. And root locus rules govern how the poles evolve as gain changes. That's very important, because poles matter for system stability, okay. And the stability high, low sensitivity, sensitivity more, okay, then less stable, right? So that's the things we need to understand, because gain is plays important role, okay. So because gain changes, of course poles going to shift somewhere. So we need to appropriately we need to change the gain. We will change, like in our practical scenario, if you potentiometer, now we are going for digital controller. So in software generally we can do, okay, tuning part. But in case of our analog controller, we require some potentiometer, some gains required. You need to do some gains, okay. Potentiometer you just change some. So if you change some gains, it means we are changing the poles in control perspective. All right. So let us coming back to our question and try to solve, and just be applying the third rule 3, rule 3 I think, and we will solve this question, okay. So let us read out again this question. So open loop transfer function for system shown in figure is gs equal to k into s into s plus 2 by s plus 5 into s plus 7. So I am just already uh, presenting the poles and zero in the our complex plane. So they are asking in the which following real axis point are in the root locus. So as we know, like let us distinguish here this this region and this region, okay, and this region and this region and this region, okay. So 1 2 3 4 5 regions there. And let us say they given these points -1 -4 -6 -10. So this is 0 -2. If you stay here and only one pole, only 1 0 there, right? So 1 0 means, of course, this is like odd, okay. So this is applicable. So this lie on the root locus, this branch, okay. So this branch is 0 to -2, this will be lie on the. So in this region -1 also will be there, so this also correct. Let us check out one more point. So -2 -5 in this, if you stay there, in this we will write, if you look into right of the explain right, just right from this point, so we'll get the 2 0. So this is a, we want number of poles and 0 is a odd. Okay, so this is a win, so it will not, this branch will not be lie in the root locus. All right, otherwise will not fulfill our phase condition, odd multiple of the 180 degree. So minus 4 will not be there. And then come back to our again minus 5 to minus 7. If you look into this, then we will lie the 3 2 0 1 pole. Okay, so this will be lie, and minus 10, minus 10 here, minus 7 here, so this will not also part of this. So let us redraw this again, and I am just highlighting here minus 0, minus 2, so this will be lie, and minus 5, minus 5 is our pole. Let us draw in a cross, present cross, and minus 7. Alright, so this branch and this branch will be lie. Alright, so our answer, this is like multiple choice question. Okay, MSQ type of question. So here option will be A and C. Okay, if the question they ask real axis are on the root locus, not on the root locus, then option will be B and D, minus 4 and minus 10. Okay, so that's a very important question, and it's a very conceptual question. All right, if you know the concepts, so only in order to solve this question, what's the rule, only we need to understand rule number 3, real axis rule, right? So point on the real axis lie on the root locus if total number of the open loop poles and 0 at the right of the point is odd. Okay, so this is very simple rules. If you remember this, we can apply and get the solution. So that's all for this video. Thanks all.